Students will see some numerical sums. The second chapter, electrostatic potential and capacitors. First one, 2 point charges 60 nano minus 40 nano are placed 20 centimeter apart. At what point on the line join the two charges is electric potential 0? At what points? That's very, very important. 2 points identify ಮಾಡಬೇಕು. First of all, the hints here in this problem, electrostatic potential, we have learned in detail electrostatic potential, amount of work done in moving unit charge from infinity to that point against the field. According to our derivation part, the value is Q by R. Here he says there are two charges. Charge at say position A, Q1, 16 nano 10 power minus 9 coulomb. We will use it while substituting the value. Second one, point B, their charge Q2 having minus 40 nano coulomb. This is the line joining them, a line which passes through them like this. Right? Here may be a midpoint, this one may be a midpoint, but electrostatic potential 0 agbeku depends on the value of the charge. Charge more, potential more. So when charge is more, distance will be more to have the same ratio. E point nalli charge to distance ratio. First point ಇದೆಲ್ಲ ಪಾಯಿಂಟ್ ಎ, ಅಲ್ಲಿ ಚಾರ್ಜ್ ಟು ಡಿಸ್ಟೆನ್ಸ್ ರೇಷಿಯೋ ಒಂದೇ ಇರಬೇಕು. ಹಾಗಾಗಿ ಚಾರ್ಜ್ ಜಾಸ್ತಿ, ಡಿಸ್ಟೆನ್ಸು ಜಾಸ್ತಿ. ಲೆಟ್ ಅಸ್ ಸಪೋಸ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟು ಚಾರ್ಜಸ್ ಎ ಬಿ ಮಧ್ಯೆ a point, let us call that point some point P ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, where potential is supposed to be 0. That point say at a distance x from smaller charge ತಗೋಣ. ಹೀಗೆ ಯಾವುದಾದ್ರು ತಗೋಬೋದು. -2, we can take plus also. Then the total distance between the two charges 20, he says in the problem. Remaining distance from point A, that is charge Q1, 20 minus x. This distance 20 minus x. That's it. Very simple. Now you consider the situation. He says first point, what I am discussing is first case, number 1. Okay, because he says there is another point where ಈ ಎರಡು ಚಾರ್ಜ್ಗಳ ಮಧ್ಯೆ the charge lies between the 2 points. Point lies between the two charges. The other one point lies outside the two charges. Distance between the two charges ಏನಿದೆಯೋ ಅದರ ಔಟ್ಸೈಡು. ಚಾರ್ಜು Q2 ಸ್ಮಾಲ್ ಇರೋದ್ರಿಂದ ಆ ಕಡೆಗೆ ಆ ಪಾಯಿಂಟ್ ಇರಬೇಕು. ಯಾಕೆಂದರೆ ಇದರಿಂದ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಜಾಸ್ತಿ, ಇದರಿಂದ ಕಮ್ಮಿ. ದಟ್ಸ್ ವೈ ಮೇ ಬಿ ಈ ಪಾಯಿಂಟ್ಗೆ ನೋಡಿ, ಇಲ್ಲೆಲ್ಲೋ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ನ ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್. ಮ್ಯಾಥಮೆಟಿಕಲಿ the total potential will be 0. We will see it. ಈಗ ನಾವು potential is a scalar quantity. That's why resultant potential must be sum of the potentials of the two charges, charge Q1, charge Q2. He says the total value 0. What is potential of first charge? 1 over 4 pi epsilon 0 charge Q1 divided by R distance 20 minus x is not squared. Remember, square ಬರ್ಕೊಬಿಟ್ಟಿರ. Some of you make that mistake. Generally for potential square ಹಾಕೋಬಿಡ್ತೀರ, because electric field and force square ಹಾಕೊಂಡಿರ್ತೀರ. That's why ಅದನ್ನು ಕೇರ್ಫುಲ್ ಆಗಿ. Minus 1 over 4 pi epsilon 0 charge Q2 divided by R distance, that is x. Why minus? In fact, if I write plus, you must write minus. This is negative charge. The common term 1 over 4 pi epsilon 0 goes this side. 0 ಆಗೋಯ್ತು. So you are left with on the left side 0. Q1 divided by 20 minus x. Minus into plus minus Q2 divided by x. So I can write this way. Bring it to left side. That is Q2 divided by x. I have brought this to left side, and on the right side you have Q1 divided by 20 minus x, and you put the value of charge Q1, 40 10 power minus 6 divided by x, that equal to 60 60 nano, he says nano, 10 power minus 9. 10 power minus 9 divided by 20 minus x. 1 power gets cancelled. So you have on the left side 40 divided by x. On the right side 60 divided by 20 minus x. There is a common factor here. 2 2s are 2 3s are. So if you just cross multiply 2 to this side, this left side and this right side, you have 2 times 20 minus x, and this is 3x. I can continue this way. 40 minus 2x, that equal to 3x. So 40, that equal to 5x. The value of x finally 8 centimeters. That's it. Therefore 20 minus x turns out to be 20 minus x 8, that's why it's 12 centimeters. So your answer, you present your answer like this. That is neutral point, null point, you can say, point where the potential is 0. The point where potential 0 is at I write both at 8 centimeter from minus 40 nanocoulomb and 12 centimeter from 60 nanocoulomb. Like this we present answer. If they ask specifically from 40 nanocoulomb or negative charge, you answer 8 centimeter. From positive charge, you write answer 12 centimeter. Generally, if they ask like this, whether to find positive or negative, not clear in the problem. Answer. Write this way. Is enough. So, Nemo, as I told you, what do you do? Once you look at the problem, pass. You try it on your own. Then, all steps check ಮಾಡ್ಕೊಳ್ಳಿ. Have you done it properly? ಏನಾದರೂ ಮಿಸ್ಟೇಕ್ಸ್ ಇದೆಯಾ? Simplification of the problem is, you can inform me, right? We'll move on. Students will move on. The second one is almost similar to the previous chapter problem regarding a square. Let's read now. ABCD is a square having side length 3 meter and having charges 6, 8 and 6 microcoulomb placed at the corners AB and C respectively. What is the work done transferring a charge 2 micro from the corner D to the point of intersection diagonals? That's this. So for square, you're very familiar. Side length A idre, diagonal lengths ABCD. A times root 2. You know this formula, get it by heart. 3 root 2. If it is in centimeter, 10 power minus 2. But in meter, you don't add 10 power minus 2. And from the center to the corner, the distance A by root 2. A by root 2 is diagonal. This formula, get it by heart. Pythagoras apply ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. Now, the hint is same. Here also you will use the formula potential 1 over 4 pi epsilon 0 Q divided by R. Now you pause the video, try on your own, then compare your calculation with my calculation here. Now, you have to find work done. What is work done by definition? Charge into potential difference. Charge into PD. You are very familiar with this. Because PD is work per unit charge ratio, that's why. Here, charge times, what is potential difference? Since you are moving from corner to the center, you have to find potential at center minus potential at the corner. Take it equation number 1. You find potential at point O, which is the center of this diagonal square, and potential at corner D. This calculation is very simple. You have done it several times in your regular class. We have solved number 1, potential at O. Potential at O. You know the formula. Since potential is a scalar, just V1 ಬರ್ಕೊಳ್ಳಿ. V1 due to first charge Q1 at corner A, V2 second charge Q2 at B, and V3 third charge Q3 at C, Now V0 ಎಲ್ಲ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಹಾಗೆ ಮೈಂಡ್ ಹೇಳ್ಕೊಳ್ಳಿ. ವಾಟ್ ಇಸ್ ಪೊಟೆನ್ಷಿಯಲ್? 1/4πε0 Q divided by R. Here 1/4πε0 is a common term which appears in all the three right hand side terms. Charge Q1 divided by corner A to center O. You are finding potential at center O, charge is at corner A. Q2 divided by BO plus Q3 divided by CO. Since AO that equal to BO that equal to CO, you can put for all BO CO AO ne. ಹಾಗಾಗಿ 1/4πε0 Q1 plus Q2 plus Q3 whole divided by AO, because BO CO also AO. So put the values. 9 10 to the power 9. The charges. The value of first charge 6 plus 8 plus 6. They are micro. So you take that micro, which is 10 power minus 6 outside. Outside you write like this. What is AO? AO is S 3 by root 2. 3 by root 2. So the final expression, final calculation part is VO potential at corner O is 9. Here 9. This comes to, okay, just a minute. 9. This denominator term root 2 comes to numerator, divided by 3 3s are in fact, you can calculate it out. I'll remove that here itself. You can do simplifications like this. 3 root 2 times 6 plus 6 18 12 plus 8 20 10 raised to the power plus 3. That's it, plus 3. That's the value. So the final value of this, yes, the value 8.48 10 power 4 volts. Check it once. Now potential at D, same procedure. VD potential at D due to first charge, due to second charge, due to third charge, and the values, all these things will repeat. Procedure routine 1/4πε0 charge Q1 divided by AD plus Q2 divided by BD is diagonal, remember here slightly different substitution. Q3 divided by CD. Now you can CD AD that equal to CD yes, that equal to 3. That's why you can group the two terms together so that the value will be easy for calculation. Q1 plus Q3 that divided by AD plus Q2 divided by BD. ಇವೆರಡು ಸೇಮ್ ಇದೆ ನೋಡಿ, ಹಾಗಾಗಿ ಇಲ್ಲೂ AD ಬರ್ಕೊಂಡ್ರೆ ಸೇಮ್ ಟರ್ಮ್ ಆಯಿತು. ಡೈರೆಕ್ಟ್ ಬರೀಬೋದು. Now substitute the values. 9 10 to the power 9. Here Q1 Q2 6 plus 6 divided by side length 3 plus Q2 8 divided by diagonal S. Diagonal is A root 2, 3 root 2, and the power into 10 to the power minus 6. That's it. Now VD, so 6 plus 6 12, 3 4s are 12, right? 3 4s are, and you can simplify. You try it. 9 times 4 plus 8 by 3 root 2. Do it with your calculator. 10 power 9 minus 6, that is plus 3. 9 minus 6 plus 3. Here you do power 9 minus 6, that is plus 3. Right? Okay, if you do the simplification, is the value of this product 5.30 10 power 4. That's it. Now you come to the required calculation, that is work done. Use equation number 1 written above here. W charge times potential difference VO minus VD. You are moving to the final position O, the center of the square, from the side corner D. Now write the value of the charge. What is the charge to be moved? 2 micro charge you are moving from the corner D to the center of the square. VD here we have found VO 8.48, 8.48, 10 raised to the power 4 minus 5.30, 10 raised to power 4. Here power of 10, 8.48 minus 5.30 into 10 power minus 6, 10 power plus 4. So the value of W is, next third one is a continuation of first one in fact, but sometimes they ask separately. They find a point where potential is 0 in between the charges or outside the charges. But actually in the first problem, they have asked to find the points. Here itself should have found both the points, point inside, point outside. Now, this calculation third problem ಮಾಡ್ತಾನೆ because ಒಂದ್ಸರಿ find the point where the potential is 0 on the line join the two charges in between the charges. Next outside the charges. ಹೇಗೆ ಕೇಳಿದ್ರು ಮಾಡಿ, ಏನೂ ಕೇಳ್ದೇ ಪಾಯಿಂಟ್ಸ್ ಕೇಳಿದ್ರೆ ನೀವು ಒಂದನ್ನು ಮಾಡಿ, ಬರೀ ಪಾಯಿಂಟ್ ಅಂತ ಕೇಳಿದ್ರೆ ಯಾವ್ದು ಮಾಡಿದ್ರು ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ. A point inside, a point outside. Now let's see, same diagram, no change. Separation 20, charges 60, minus 40 nanocoulomb. Look here, okay, I have written the same procedure. Total potential resultant that equal to V1 plus V2. Just a repeat problem. 0, that is 1 over 4 pi epsilon 0 charge Q1 divided by Q1 is plus 60. Previously we wrote 20 minus x, but here it is plus x. Charge negative ಇದೆ, minus q. ನಾವು ಮೈನಸ್ ಇಲ್ಲೇ ಬರ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಮೈನಸ್ 1 over 4 pi epsilon 0 q2 divided by x. 1 over 4 pi epsilon naught ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ 0 ಆಯಿತು. ಸೊ ಯು ಹ್ಯಾವ್ q1 divided by 20 plus x that equal to q2 by x. q1 60 nanocoulomb divided by 20 plus x that equal to 40. Minus and ಮೊದಲೇ ಬರ್ಕೊಂಡಿದ್ದೀನಿ ನೋಡಿ ಇಲ್ಲಿ. That's why I am not writing minus and again. So x nanocoulomb cancels. You have and 0 and also 3 is a, this 2 is a. So you have on cross multiplication x to the left side and 20 plus x to the right side, 3 times x that equal to 2 times 20 plus x. Clear the bracket. 22 is a 40 plus 2x. So you bring it to the left side. You have 3x minus 2x that equal to 40. 40, okay. Okay, so the value of x will be 40 centimeters. You are writing in centimeters, the answer also is in centimeter. So finally, how do you present your answer? Distance of point where potential is 0 is x 40 centimeter from minus 40 nanocoulomb and 20 plus x, because nodi illinda illige 20 and further x, so the total value x 40 plus 20 60 centimeter from the second charge, which is 60 nanocoulomb. Move on, children. Fourth one, charges 4 microcoulomb, 6 micro, 8 micro are placed at the corners A, B and C, big C, of a square ABCD having side length L meter. What is the magnitude of charge that must be placed at the corner D so that the potential at the corner center is 0? Potential at the center is 0 at only one point. And we have solved a problem like this. Potential at a point is given by, as it is a scalar quantity, 1 over 4 pi epsilon 0 charge q1 divided by that distance AO. You are finding potential at the center O of a square, that is q2 divided by BO plus q3 divided by CO plus q4 divided by DO. That's it. The problem is very similar to the previous one. That is, there is a square. Square ಅಂತಿದ್ದ ಹಾಗೇನೆ you will know the diagonal length AC BD, that will be equal to side length times root 2. A root 2. If side is A, here it's L, value is not given, L root 2. ನೋಡಿ ಸೈಡ್ ಲೆಂತ್ ಕೊಟ್ಟಿಲ್ಲ ಅವರು. ಡೋಂಟ್ ಬಿಕಮ್ ಪ್ಯಾನಿಕ್. ಇಲ್ಲಿ ಸೈಡ್ ಲೆಂತ್ ಯೂಸ್ ಆಗಲ್ಲ ನೋಡಿ, ಅದು ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬಿಟ್ಟು. ದಟ್ಸ್ ವೈ ಸಮ್ L he has assumed. You have to find potential at the center. We have solved numerical problems, potential, finding potential at O, potential at D, potential at C. To start with simple problems ನಾವು ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸಸ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀವಿ. ಈಗ potential at given that potential at O 0, why 0? He says that. So 1 over 4 pi epsilon 0 charge Q1 plus Q2 plus Q3 plus Q4 divided by AO. Or you can write instead of AO that equal to BO CO DO L by root 2. ನೋಡಿ, ಇಷ್ಟು ಕಾಮನ್ ಇರೋದ್ರಿಂದ you can cross multiply to 0. So rest the whole thing will be 0. 1 over 4 pi epsilon into 0, L by root 2 into 0, 0. So left side will be 0. You have only charge sum Q1 plus Q2 plus Q3 plus Q4 on the right side. Put the values. 0, 6, actually it's 4 plus 6 micro plus 8 micro plus Q, you call it 4, Q4 at the fourth corner. That's it. The product is 6 4 10, 18 microcoulomb plus Q4. You send this to left side. So mathematically it becomes negative minus 18 microcoulomb. What's the answer? Minus 18 microcoulomb. That's it. It's very simple. The point is potential at the center 0. Potential at a point is sum of the ratio Q1 by distance, Q2 by distance, Q3 by distance, Q4 distance ಸೇಮ್ ಇದೆ. ಸೊ ನೀವು ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ಈ ವ್ಯಾಲ್ಯೂ. That's it. We'll see one more statement on capacitors. Parallel plate capacitor, air capacitor, in fact, this capacitor has plate area 8 square mm square, you can say mm square, and distance between the plates is 4 mm. Calculate capacitance. Also find the charge on the plate if a PD of 200 volt is applied. Here the hint is capacitance relation. All of us familiar with epsilon 0 A divided by D. If it is a air capacitor, dielectric constant is 1. If it is a capacitor with a medium, let us write air capacitor Ca, medium capacitor Cm. Recall your relation, epsilon naught K A divided by D. If area is, say, like circular plate, pi r square. Length into breadth, if it is rectangular. Square plate, A square. Side length is A. Like that, we will make a substitution for the area. Here area is given. So let's start with this. Epsilon 0, the value of constant 8.854 10 to the power minus 12 into area is given 8 square centimeter, millimeter, milli 10 power minus 3 meters whole square. This part you have to square. Divided by separation 4 mm 10 power minus 3. So the value of capacitance, you try, 8.854 into 8 divided by 4. This is the part of numerical calculation. The power minus 12, and this is minus 2 3s are 6, and this comes to numerator becomes plus 3, and the final value, if I do with my calculator, capacitance with medium air, it says, check it out once, 7.71 10 to the power minus 15 farad unit of capacitance. As I explained in the last class, previous video, unit very important. You do every calculation. You identify correct relation, make substitution properly, solve power properly, but forget to write unit, losing 1 mark. Don't do that, right? The one part of the calculation. Second one, charge value. What is charge? Charge Q that equal to CV. And C already found 17.71 10 to the power minus 15 into the value of PD 200. So the value of charge, product of these two, 3s are 35 point something, 35.4 10 to the power minus 13. If you write 3.54 10 to the power minus 12, what is the unit of charge? Coulomb. That's it. Next one, children. Plate area of a parallel plate capacitor is 2 mm and 3 mm and distance between the plates 1 mm. Calculate the capacitance and charge on the plates if charge the plates if a PD should be PD of 150 volt is applied. He has given area in terms of length into breadth. That's what I told you, right? ನೀವು ಏರಿಯಾ ನೇರ ಕೊಟ್ಟಿದ್ರೆ ಅದನ್ನ ವ್ಯಾಲ್ಯೂ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಹಿಯರ್ ಈ ಗಿವ್ಸ್ ಏರಿಯಾ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಲೆಂತ್ ಆ್ಯಂಡ್ ಬ್ರೆಡ್ತ್. ಇಸ್ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಪ್ಲೇಟ್, ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ parallel plate capacitor. One plate, the other one like this. One acquires positive charge, the other acquires negative charge. That the separation is given. This part very familiar to you. You have learned theory. What's the length? 2 mm 10 power minus 3. Area 3 mm 10 power minus 3. So the area 2 3s are 6 10 to the power minus 6 meter squared. It should be in SI units. Now simple, capacitance epsilon naught A divided by D and epsilon naught 8.854 10 to the power minus 12 into area. What is area? 6 10 power minus 6 whole divided by separation 1 mm 1 10 power minus 3 meter. So the value of capacitance C, the value is coming around my calculation 5.31 10 to the power minus 12 farad. The value of capacitance. Check this value once. The rest is same as the previous capacitance CV. Only difference is finding area separately here in this. 5.31 10 to the power minus 12 into 150. So the value of Q coming around 7.96 10 to the power 965 he says 10 power minus 10 coulomb unit of charge, or you can round it off. ನೋಡಿ 5.965 ರಿಮೂವ್ ಮಾಡಿದ್ರೆ 6 becomes 7 more than 5. That's why 9ನ 10 ಮಾಡ್ತೀರಾ, ನಿಯರ್ಲಿ 8 10 to the power minus 10 coulomb. Like this you can write. If you stop here itself, no problem, it will be given full marks. ಫುಲ್ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ. ಯೂನಿಟ್ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಯೂನಿಟ್ ಬರೆಯೋದನ್ನು ಮರಿಬಾರ್ದು ನೀವು ಯಾವುದೇ ಕಾರಣಕ್ಕೂ. ಯೂನಿಟ್ ಪ್ಲೇಸ್ ಅ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ರೋಲ್, is very important. They observe this unit as practice. ಫಿಸಿಕ್ಸ್ ಇವ್ಯಾಲ್ಯೂಯೇಟರ್ಸ್ ಅಂದರೆ ಯೂನಿಟ್ಸ್ ನೋಡ್ತಾರೆ, ಬೈ ಪ್ರಾಕ್ಟೀಸ್ ಬಂದುಬಿಟ್ಟಿರುತ್ತೆ. ಈ ಥರ ಯು ವಿಲ್ ಲರ್ನ್ ಆ್ಯಂಡ್ ಇದೇ ಥರ ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡು ನೀವು ಹೋಗ್ಬೋದು. ಆ್ಯಂಡ್ ಸಮ್ ಮೋರ್ ಸಿಮಿಲರ್ ಟೈಪ್ಸ್ ಯು ಹ್ಯಾವ್ ಸಾಲ್ವ್ ಇನ್ ದ ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸಸ್. ಅವನು ನೋಡ್ತೀವಿ ಬೇರೆ ಬೇರೆ ಟೈಪ್ಸ್. ಟ್ರಯಾಂಗಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಯು ಹ್ಯಾವ್ ಸಾಲ್ವ್ ವಿತ್ ಫೋರ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್, ಪೊಟೆನ್ಷಿಯಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್, ಚೆಕ್ ಬೇರೆ ಬೇರೆ ವೆರೈಟೀಸ್ ಸಾಲ್ವ್ ಮಾಡಿ ಸರಿ ನೋಡ್ಕೊಳ್ಳಿ ಈ ಜೊತೆಗೆ, ರೈಟ್. You have to practice. If you don't practice problems, normally you don't develop sort of fluency. Mistakes ಮಾಡೇ ಮಾಡ್ತೀರಾ. ಹಾಗಾಗಿ ಕಂಟಿನ್ಯೂ. Move on. Seventh one in this chapter, plate area of a parallel plate capacitor, okay, is 50 square centimeter and separation, right, separation is 1.5 mm. If a PD of 400 volt is applied, find energy stored in the capacitor, energy expression. If a dielectric constant 2.5 is introduced between the plates, find the energy stored and also find the change in energy stored. Actually, there are three parts, separate parts. Let's now think of the energy expression here. What is energy expression? Energy you can write simply U for potential energy 1 over 2 QV, one relation, one of the forms. Second one, CV squared. Third one, half Q square by C, three relation. We'll be using this middle one. Depending on situation, we'll use. Now the first one, A, you have to find energy stored in the first case. To find energy stored using middle relation, we have to find capacitance. He has not given charge. For the first and last relation, charge is required. First finding the charge, then continuing is bit lengthy calculation than finding first capacitance. What is capacitance? Same parallel plate capacitor expression. Air capacitor, this one. That's why epsilon naught A divided by first case air. That's why. Second case medium. In that case you have to write K times. K times you have to write. Now K is not required. Just only epsilon 0. Okay, right? So 8.854 10 to the power minus 12 into what is the value of A area? Area he says 50 square centimeter. 50 10 to the power minus 2 meter whole square divided by separation between them 1.5 mm 10 power minus 3 meter. And if you find the value of capacitance, I have done it for you. You try it once again. 2.95 10 to the power minus 11 farad. This is the value of capacitance. Now the first part, A. You have to find energy with air as dielectric. I write U subscript A to indicate that it is air capacitor. Half C, let's write Ca, capacitance Ca, and PD squared. PD is given half into the value of Ca, 2.95 10 to the power minus 11 into the value of V. V is actually 250 squared, right? 250, maybe 250, yes, 250 squared. Potential is actually 4, he says 400 is 400. I remove the 250. Okay, 400 square. So the value of energy stored with air as medium. Okay, the value 2.36 10 power minus 6 joule, right? Now he introduces a medium. Dielectric constant K 2.5 has been introduced. Then if dielectric constant is this, then capacitance with medium, capacitance with where times dielectric constant, because dielectric constant is defined as ratio of capacitance with medium to capacitance with air. That's it. Yes. Therefore, let's write the expression for energy stored with medium. Therefore, energy with medium, that is half of capacitance with medium. Potential difference is same, V square. So half of, what is the value of Cm now? Cm is K times Ca into V square. That's it. So that equal to, I write K outside and in the bracket half Ca V squared. What is Ca V squared? Must be smart enough here. Ca V squared already you have found. ನೋಡಿ ಈ ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿದ್ಬಿಟ್ಟಿರ. ಮತ್ತೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡೋ ನೆಸೆಸಿಟಿ ಬೇಕಿಲ್ಲ. ನೀವು ಅದು ಮಾಡಿದ್ರಿದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ನಲ್ಲಿ ಸ್ವಲ್ಪ ಹಿಂದೆ ಇದ್ದೀರಾ. ಸ್ಮಾರ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಬಿಕಾಸ್ ಆಲ್ರೆಡಿ ಯು ಹ್ಯಾವ್ ಫೌಂಡ್ ಹಾಫ್ Ca V square, ರೈಟ್? ದಟ್ ಈಸ್ UA, ಅಂದರೆ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ವಿತ್ ಏರ್ as medium. That's why K value 2.5 times the value of U, which is 2.36 10 to the power minus 6 joule. The value of energy stored with dielectric constant as the medium is coming around 5.9 into 10 raised to the power minus 6 joule. This is the value of energy with medium. Now he wants one more. See, what is change in energy? Change in potential energy. Change in potential energy can write delta U, which is U with medium more, U with air. So U with medium is coming around how much? 2 point with medium 5 point. I write that first. 5.9 10 to the power minus 6 minus 2.36 10 to the power minus 6. So the value of change in energy, that is 5.9 minus 2.36, coming around 3.54 10 to the power minus 6 joule is the change in potential energy when a dielectric constant of 2.5 is introduced. This way you can practice. Children, the last one here in this type, a capacitor with a plate radius 2 cm and separation 1 mm is placed, is applied with a PD 300 volt. Calculate energy stored in it. Here he gives a circular plate capacitor. Circular plate not mentioned. From the problem itself you will understand radius means it's a parallel plate. Plates are circular. So he gives a radius, that is 2 centimeters. Therefore 2 10 power minus 2. Therefore for area we will make a substitution pi r square. That's it. Now first of all find the capacitance. C epsilon naught A by D. He is not mentioning anything about the dielectric constant. That's why it must be air. Epsilon 0 area of the plate pi r square divided by separation D. Therefore C capacitance epsilon 0 8.854 10 raised to power minus 12, pi value 3.14 and radius 2 10 power minus 2 whole square whole divided by separation 1 mm 10 power minus 3. If you do simplification as I explained you earlier, you are getting 11.12 10 to the power minus 12 farad. Picofarad you can write 11.12 pico. It's not necessary to write this way, mandatory, but we can express this way. If they ask in picofarad, in nanofarad, in micro, additional question for which you lose 1 mark. Pico ಅಂತ ಕೇಳಿದ್ರೆ pico 10 power minus 2 ಕನ್ವರ್ಟ್ ಮಾಡಿಬಿಡ್ತೀರ. ಅವ್ರು ಕೇಳಿದ್ರೆ ಹಾಗೆ ಬರೀರಿ microfarad to test you whether you are understood or not. Micro, pico, ಆ ಥರದ್ದು is enough. ಇಷ್ಟು ಸಾಕು. ನೆಕ್ಸ್ಟು energy stored. What is energy stored? Half CV squared. You are using only this. Why? Because capacitance given, potential difference given is 11.12 pico 10 power minus 12 times what is the value of V? V value here is 300 whole square. So U that equal to, if you simplify completely, getting 5 10 raised to power minus 7 joule. Do the simplification part. How do you do? 300. 3 10 power 2 whole square. There is a 9 10 power 2 whole square. For final value is coming out 5 10 power minus 7 joule. This way we will try. And some more types we have solved in a regular class. I don't know. So this way you can try problems. We'll continue further, students.